Alright, so here's a bit of a bonus video. I want to talk a little bit about interrupts as they relate to the latest lab you've been working on. The topic here is nested interrupts and side effects, and these are related to each other. So let's think about how a basic delay loop works. You have a set of code called delay, and what this basically does is inside there's a tenth of a second delay loop, a set of code which takes a tenth of a second to execute. And outside you have an instruction that moves contents of W into, I think it's called count OD, and then repeats this loop until count OD equals 0. And at the bottom it does a decrement on count OD. So that's the outer loop. Okay, so you move a value into W, for example, move LW5, and then you call delay. And what's happening? You come to this routine delay, it puts a 5 into count OD, it executes this set of code that takes a tenth of a second, and then it subtracts 1 from your count. So now your count goes down to 4. It's not 0, so it goes back, waits another tenth of a second, decrements the count to 3. It's still not 0, it goes back, decrements to 2, goes back, decrements to 1, goes back a fifth time, waits a tenth of a second, decrements the count to 0. Since it's equal to 0, it goes ahead and it does your return. The net effect was, because you put 5 in the W, this loop, this outer loop in the delay routine, executed this tenth of a second internal delay 5 times. So you got a 5/10 of a second delay. Now if I had moved a 15 into W and then called delay, exactly the same thing happens, except this inner loop, this tenth of a second delay, happens 15 times. Because count D starts off at 15, decrements to 14, 13, 12, 11, 10, all the way down to 1, down to 0, and then when it decrements to 0, this branch of not 0 to the top fails and it returns. So this code gets executed 15 times, 15/10 of a second delay. So we think of delay as a routine that basically whatever value we have in W when we call delay, this will wait that many tenths of a second. 15/10 of a second in this case, half a second if we put a 5 into W, exactly 1 second if we put a 10 into W. Okay, that all works great until we start dealing with interrupts. And here's what can happen with an interrupt. So you've got your code on your EDBOT, it's blinking an LED on and off, half second on, half second off. So it's continually moving a 5 into W, it's calling delay, it's toggling the LED, and it goes back, calls delay again, toggles the LED, and so on and so on. Okay, that's fine, but if you get an interrupt, like when you press an interrupt button on the EDBOT, chances are you're probably inside this delay routine when the interrupt occurs. Okay, so here's what's happening. We've got this outer loop, it's counting down. Let's say we're doing a half second delay, so it's 5. It waits a tenth of a second, it counts down to 4, it waits a tenth of a second, it counts down to 3, and while it's inside here, suddenly you get an interrupt. Okay, so you get an interrupt. You vector to location 8, that jumps to your H-prio code, and now you're executing your interrupt code, and your interrupt is using the delay routine because it wants to spin your bot for 2 seconds. So it says move a 20 into W and call delay. And delay kicks in and it executes this tenth of a second delay 20 times while driving the motors forward, so your bot is spinning clockwise for exactly 2 seconds. And when it's done, it does a ret fee, which should bring you back to where you were. Okay, here's what happens though. Inside your interrupt routine, you call delay. You set count D equal to 20. You go through here, you decrement count D to 19, you go through again, decrement it to 18, and so on. You decrement it to 1, you go through a tenth of a second delay, you decrement it to 0. Count out D is now 0, so you return from the delay routine, which brings you back here, and now you do your ret fee, and now you come back to where you were when you got interrupted, which was somewhere inside here. Okay, you finish out that 1/10 of a second. What does the code in delay do? It decrements count. So this gets decremented from 0 to 255. It's not 0, so it goes back, waits another 1/10 of a second, decrements to 254, goes back, decrements to 253, and so on, all the way down until this becomes 1 and then becomes 0, and then this will return, and now you're back from your original call. But because this got set to 255, 25 and a half seconds that you're sitting inside this call to delay. So this is a classic side effect, right? We put a 5 in W, we call delay, we expect it to return after 5/10 of a second, but we got an interrupt and something happened in that interrupt which changed the value of this. Remember, when the interrupt occurred, this was equal to 3. When the interrupt finished, this was equal to 0. And so if we're inside this delay loop and count is equal to 3, and magically all of a sudden count changes to 0, what happens when we get to the end of the loop? We decrement count, it becomes 255, it's not 0, we go back and we loop again, and now we're going to loop here for 25 more seconds. So that's why after your bot spins, your LED stops blinking for about 25 seconds, and then it goes back to it. Okay. This will also kick in if you have nested interrupts. Remember, we have 2 priority interrupts. We have a high priority and a low priority. If you flip the low priority interrupt and your bot starts spinning one direction, and while it's spinning, you flip the high priority interrupt, that will interrupt your low priority code and start spinning the bot in the other direction, and it will spin for 2 seconds. But when it finishes spinning, it's going to go back to the low priority code, which was probably using the delay routine that was also used by the high priority code and was also used by your main program. So that high priority interrupt disturbs this count variable in your low priority routine, and now your bot's probably going to spin for 25 seconds. And then when it comes out, your LED is probably going to stay either on or off for 25 seconds. Okay, so these are side effects. It's the interrupt doing something other than what you intended it to do. In this case, changing the value of count OD. And there's 2 really quick ways to deal with this. One way to deal with this is to just preserve any variables that you're going to disturb in your interrupt routine. So in the beginning of our high priority interrupt, we could move count OD to some save location, and inside here there's a count ID. We could copy that to some other save location, go ahead and call our delay, and then before we do our ret fee, restore count ID and count OD from where we saved them. And that's going to work beautifully. Okay, but if we're also going to call delay in our low interrupt routine, we need to save count OD and ID in a different set of locations, right? Why? Because we don't want to overwrite the locations that we might have saved these in our high priority routine. So every time that you call delay, before you do that, save your count variables somewhere, and then when you come back from delay, restore those count variables. And you're just acknowledging the fact that this call is going to change the contents of some file registers whose values might be important to you. A less painful way to think about doing this, but it takes a little more typing, is to not call delay from the interrupt routine. Make a copy of this that uses different file registers for count OD and count ID. Call it delay 2, and in your high priority routine, call delay 2. And in your low priority routine, call a third delay routine called delay 3, or call it delay high, delay low, something reasonable. And as long as each of those delays use different file registers from what the other delays use, you're not going to get this kind of interference. So that first approach is more sort of generally usable. You can extend that by using things like stacks so that you can call this delay routine from multiple locations. But for a quicker and slightly dirtier solution, you can just have different delay routines, delay 2, delay 3, and that'll take care of it. I'm not assessing you on being able to handle nested interrupts like this, but I do want your LED hopefully to go back to blinking on and off half-second period once you come out of the interrupt. So doing one of these approaches to saving your variables or using a different delay routine should take care of that. All right, just something to think about with interrupts. Interrupts are definitely complicated, right? Because largely of these side effects and because of the unpredictability of when an interrupt is going to occur. And something as harmless looking as this, we're just going to call our delay routine, can actually interfere with what your code was doing depending on where it was. All right, just some stuff to think about. Thanks.